Hi everyone, this is Mr. Siu from Math Accelerator Center. Welcome to P5 SA2 Mini Revision Lesson 3. Today we'll be covering the topic on volume. I'm sure everybody knows that volume centers on only one formula. So to find the volume of the container or the mass of water or the volume of the water, you only need to take length times breadth times heights. Okay, I have prepared three problem sums involving volume, and they each have a different focus. Okay, let's go through these three questions and see how we go using this formula to solve the question. So here's question 1. The figure shows the amount of water in two rectangular tanks, A and B at first. Tank A was filled to the brim and there was some water in tank B. Okay, part A is to find what's the volume of water in tank A at first. Okay, give me a moment now. Let me bring up the next part. And part B, Mr. Slim poured 1/3 of water from tank A into tank B to fill it to its brim. What was the volume of tank B? Okay, let's underline some of the keywords in the question. So we have two rectangular tanks, A and B. A is filled to the brim, and there's some water in B. First part, we need to find out what's the volume of water in tank A at first. So as we mentioned, to find the volume of tank A, we simply just multiply the length with the breadth and the heights. And we will arrive at 360 cm cubed. Okay, next, Mr. Slim poured 1/3 of the water from tank A into tank B to fill it to the brim. What is the volume of tank B? Okay, first of all, there's a transfer, right? So A, let's focus here. Let's write part B. Tank A, there's a transfer. Mr. Slim transfer 1/3 of the water into B. Of, we know, is to multiply. The volume, the water in tank A is 360. So we calculate the amount that was transferred. So 1/3 times 360, that will give us 120 cm cubed. So this amount was transferred to B. Then it says, after that, B is filled to the brim. So next we calculate what is tank B. Tank B, water at first. Okay, let's calculate the volume of water at first. Okay, give me a moment. Water at first. Okay, to calculate the water at first, we have the length, the breadth, and the height of the water level over here. So we take 10 multiplied by 4 times 4, right? And we arrive at 160 cm cubed. So to find the volume of tank B, we simply add what was at first with what was added. Okay, we added 120 from tank A, and that will give us 280 cm cubed. So that's how we arrive at the answer for this question. So part A is pretty straightforward. You just apply the formula. Part B, you have to do some calculation, okay, based on the transfer. Okay, so transfer you carry out, you need to know what's before and what's after. For example, in tank A, what was the amount, the volume of water at first, and after, how much water was added, and after you add that amount of water, what will be the volume, right? So in this case, at first there was 160. The amount of water added into tank B was 120. When we add these two together, we get 280. So that's the volume of tank B. Okay, let's move on to the next question. This is question 2. Okay, so let me read the question to you. Daryl has a rectangular block of wood with only the top face painted. A. What is the volume of the block of wood? B. Daryl cuts the largest possible cube from one corner of the block. What is the volume of the cube? And C. What is the area of the painted faces of the remaining block of wood? Okay, A is very straightforward. We just need to apply the formula to find the volume of the block, which is length times breadth times the height. And we should get this number. Okay, B will be slightly, will require us to think a little further. Daryl cuts the largest possible cube from one corner of the block. What is the volume of the largest cube? Right, from one corner of the block. Okay, let's say we cut from this corner. Okay, how do we know what is the dimension of this cube? Right, you can see that 20 cm is the shortest possible, okay, is the most for the height, right? Then that will be the limiting factor, or the shortest edge that you can, the largest edge you can find for the cube. You cannot go beyond 36. If you have 36, then you need a height of 36, right? So definitely cannot be 120. 120, you will need another, the height to be 120 and the breadth to be 120. So at most, the cube will only have the side of 120 of 20 cm. So 20 cm means we can cut this block. Right, so in this block is 20 by 20 by 20. So maybe I can draw it out over here, that this is the maximum you can draw out, right? Okay, it's limited by the 20 cm. So here is 20 by 20 by 20. So now let's calculate the volume of this cube. It will be 20 times 20 times 20, and we will arrive at 8,000 cm cube. Part C. What is the area of the painted faces of the remaining block of wood? Right. Only the top face is painted. So we have to find what was at first and what's after, right? Let's do part C over here. Now, at first, what is the area that's painted, right? So area at first. The area at first is 120 times 36, and that will give us 4320. Next, remember we cut this portion out, so we have to find the area of this square that we have cut out. So that part will be 20 times 20, we will get 400. So now we can find the area of the remaining block. So area at first is 4320, we cut out 400, and we will get 3920. So that's our answer. Okay, let's recap. Part A is easy. Part A is simply applying the formula. Part B, what's the largest possible cube you can cut from one corner, right? This one requires you to think a little further. You need to understand that the corner, okay, at most you can only cut a 20 by 20 by 20 cube, right? A cube that has 20 cm at the side. So 20 times 20 times 20 will arrive at 8,000. Part C, okay, what is the area of the painted face of the remaining block. Okay, so we need to, it's a before after situation. Before, the area is 4320. Okay, after, what do? We cut out this block. This block, the painted area over the top is 400. So we have to do a subtraction. So 4320 minus 400, we will get 3920 cm squared. Okay, let's move on to the next question. Okay, this question is a long question divided into part A and part B. So we will approach part A, answer the question first. So a rectangular tank was 3/5 filled with water at first. Nathan poured some water from the rectangular tank into a 20 cm cubical tank and filled it completely. How much water was left in the tank? Cubical tank. So let's underline this part. And it was the rectangular tank is 3/5 filled with water. Nathan poured the water from the tank into the cubical tank to fill it completely. So how much water was left in the rectangular tank? So it's a before and after situation. Before, we need to find out how much water is over here. So we write here water at first. Water at first, it says is 3/5 filled. So it's 3/5 times 50 times 28 times 30. That will give us 25,200. Cubical tank means all sides are equal. So it's 20, here is 20. So let's find the volume of this tank. 20 times 20 times 20 is 8,000. So now we can find out how much water was left. Okay, water left. So we do a subtraction. 25,200 minus away 8,000. And we arrive at 17,200 cm cubed. So that's our answer for part A. So whenever you have a long question, right, okay, it's a favorite among the examiner to test you on the before-after concept. Okay, so we'll have to find out, example, what is the situation before, what's the change, and what's happening after the change. So in this case, before, there's this amount of water. The change is you need to pour some of this water to fill up the cubical tank to the brim. And in this case, you need to cover 8,000. After that, you have to find out how much water left. So we have to carry out a subtraction, and 25,200 minus the 8,000 that we pour into this cubical tank, and we arrive at 17,200 cubic centimeter. Okay, let's move on to the next part. Okay, maybe we can leave it here. No, I think need to scroll up. Then we were told that Nathan filled 12 bottles to the brim with water and pour all the water from the 12 bottles into the rectangular tank. There was 31 liters of water in the rectangular tank in the end. What is the capacity of each bottle? Okay, so from part A, right, we know that the water left is 17,200. So let's underline the keywords to help us understand better. He filled the 12 bottles with the water that was left, which is this amount, and pour the water from the 12 bottles into the rectangular tank. He filled, there was 31 liters of water in the tank. in the end. What's the capacity of each bottle? So what this means is, maybe I use a model to explain this. So let's visualize this as a tank. We used to have, we convert this into liters. This will be 17.2 liters, right? Because when we divide by 1,000, we get 17.2 liters. So at first, we had 17.2 liters. Then we added 12 bottles of water. Let's write over here 12 bottles. And now we have 31 liters. So now our first job is to find what is the volume of these 12 bottles. So we'll take 31 minus 17.2 and we will arrive at 13.8 liters. So from here we can find one bottle, 13.8 divided by 12, and we will get 1.15 liters, right? So our answer, we're advised to express our answer in liters, which we did. So we will get 1.15. So let's recap for this question. Now, this question requires us to have a good visualization of what the question is talking about, right? So we were told that he filled 12 bottles of water to the brim, which is these 12 bottles here, and pour all the water, okay, as the arrow has indicated, into the tank. And after pouring all this water inside, we have 31 liters of water in the tank. So we need to find what's the capacity of each bottle. So we draw a diagram here to help us visualize the changes in the volume for the rectangular tank. Okay, so we started off with 17.2 liters, which is the answer carried forward from part A. And we added 12 bottles, and in the end, we have 31 liters. So to find the volume of these 12 bottles, we just find the difference between 31 and 17.2, and we arrive at 13.8. So then we divide 13.8 by 12 to find the volume of one bottle, and we calculated, and it should be 1.15 liters. Right, as you can see, the before change after situation is very common in problem sums involving volume. So it's good that you practice this a few more times to gain confidence and mastery so as to prepare for your year-end exam. And that's the end of the lesson. I'll see you in the next one.